We'll now start building the market risk framework from the ground up. Everything that follows in this course depends on two things: market data and how we define returns. So we'll start here, keep it simple, and be very explicit about the assumptions we are making. At the top of the notebook, I import the standard Python libraries we'll use throughout the course. Pandas and NumPy handle data manipulation and numerical operations. Matplotlib is used for basic visualizations. And we also import yFinance to fetch historical market data, and norm from SciPy, which we later use for parametric value at risk. For the market proxy, we use SPY, the S&P 500 ETF. The choice here is intentional. SPY is liquid, widely understood, and representative of equity market risk. Using a familiar instrument reduces interpretation noise and lets us focus on the risk methodology rather than the asset itself. We download daily closing prices starting 2010. This gives us a sufficiently long sample that includes both relatively calm market periods and episodes of elevated volatility. We work with closing prices, which is a common choice in daily market risk applications. From prices, we compute daily simple returns using percentage changes. These returns are the fundamental input to all risk measures we'll build later: value at risk, tail losses, stress scenarios, and drawdowns. I am deliberately using simple returns, not log returns here. Simple returns map directly to profit and loss. If a portfolio is worth 1 million and the return is, let's say, minus 1%, the P&L is minus 10,000. Log returns, without a question, have useful mathematical properties, especially for compounding, but for daily market risk reporting, simple returns are standard and also sufficient. Importantly, using log returns does not remove tail risk or change the fundamental behavior of losses. It only changes the arithmetic. We drop missing values created by the return calculation, and at this point we have a clean time series of daily returns that will serve as the input to all subsequent risk models. Let's take a look at that together. So these are just the prices. You see daily prices of the SPY starting 2010, 85, and 2025, 687. Think about that in terms of how the S&P was exploding over the last 15 years. So this is quite a time horizon we're taking a look here. Keep that in mind. And you also have the returns here, also daily data, as you see, daily returns of the S&P 500. It's worth emphasizing what these returns represent. Each observation corresponds to one trading day, as you see here, right? And one realized market outcome with that. When we later talk about value at risk at the 95% level, or about the worst 1% of days, we are always referring back to this return series. So while this step looks very simple, it's the foundation for everything that follows. Before jumping into risk models, we need to understand the behavior of these returns. So in the next section, we look at basic return diagnostics, volatility, distribution shape, and tail behavior, to see why naive assumptions can be misleading.